Hello friends, previously we created CRUD application using Spring Boot, and today I want to show you the same application but using Micronaut. So today we build CRUD application with Micronaut Framework. First of all, we need to build an empty application with dependencies required for our project. So the same as a Spring Starter, we have Micronaut.io launch. It allows us to create an empty Micronaut project with all the required dependencies. So it's similar to Spring Boot, but has few differences. So let me just create my project from this Micronaut.io. So first of all, I select application type like Micronaut application. Micronaut version as default for 0.2, and I select Java version 17 as the same as we had for Spring Boot. I select the name. I can call it like CRUD Micronaut app. I select the build tool Gradle since we used Gradle previously in a previous tutorial. I can also select base package and test framework. So I need to add features to my project, and I select first of all Lombok, and I select H2 for the in-memory database. I also select JPA, data JPA, to be able to persist and retrieve the data from the database. And validation, I guess this one. I can later check if this is the same validation as I need. And I guess that's it. Let's click done. And in case we missed something, we can always add some dependencies in the process of development. Let's click generate project and download zip. I have my project, and let me open it using IntelliJ IDEA. Okay, we open the project. Let's check the structure. As you can see, it has similar structure as Spring Boot application. It also has main class, which is an entry point for our application. It also has resources folder with application properties. As you can see, since I selected H2 database, Micronaut created default configurations in my application properties for my H2 database. Since you want to change database from H2, for example, to Postgres or MySQL, you need to change these configurations accordingly. So, and I also have logback XML file for my logs output. And as you can see, the structure looks pretty familiar. Let's create a first layer. Since we built CRUD application as in previous tutorial, we're gonna create a car brand and car entity. But first of all, let's create package. We create entity package and create first entity. But instead of creating an entity, we can just copy paste it from my previous project, CRUD app example, because it's gonna be the same. Entity won't change. Let me find my entities. As you remember, we have brand entity and have car entity. Let me copy paste. And let's check if compilation is successful. As you can see, no errors. That's good. Let's create another package, and the next one is repository. First of all, we create brand repository. Brand entity repository. And we also need to extend JPA repository, but this time, as you can see, the JPA repository imports from Micronaut. and let me specify my brand entity and long as my type of private key. And as far as I remember, we had find brand by name. Let me write this method in my brand entity repository. So the purpose of this video is just to show you the differences between Micronaut and Spring Boot and show you that it's pretty similar and that you can easily start working with Micronaut if you know Spring Boot. So let me find this method, find by, and let me check, find by name. And as you guessed, Micronaut JPA repository will parse this method and prepare SQL statement to find brand entity in the database by name. And let's create another interface and call it car entity repository, and also extends JPA repository the same as we did for our previous project. And let's create some service. And IMPL package for implementation. And of course, our car service IMPL implements car service. And the differences start here. So we don't have service annotation. In the Micronaut, we need to use another annotation and to mark our class as service, we can use singleton. Singleton says that this class is singleton. By default, Spring Bean scope is also singleton, so it's the equivalent as this is the equivalent to the service annotation in Spring. And let's add required args constructor to be able to auto-wire our car repository, brand repository, and mapper. And also, if you auto-wire through the fields, for example, you can't use auto-wired anymore. You need to use inject. Inject annotation injects the dependency in the service, but since I'm using auto-wiring through the constructor along with Lombok, so I can just use private final, and I can just declare my car repository and brand repository, and Lombok will automatically auto-wire it through the constructor. So I don't need to use specific annotations. For that, let me specify car entity repository, brand entity repository, and car mapper, but I haven't created it yet, so I need to add some DTO classes. Let me copy paste it. We save a lot of time by copy pasting my DTO classes from a previous project. I copy paste along with package. Let's check if my DTO have no errors. As you can see, I correctly connected dependencies. So my validation is also working, so I don't have any compilation errors. That's good. And let's add mapper. First of all, we need dependency for mapper. Let's find it in the build Gradle. As you remember, previously we added this dependency for Mapstruct, and our Micronaut project is not an exclusion. We need these dependencies for it to be able to use Mapstruct in our project. And let me add it. This is implementation, and let's add annotation processor. Annotation processor for Mapstruct is these two dependencies. And we are ready to copy paste our mapper. We also ready to copy paste mapper in the project along with package, because we don't change any mapping logic in our Micronaut application. As you can see, I copy pasted and it works. At least it doesn't show me an error, but I need to add some changes here. As you can see, I use component model as Spring, but since I'm not using Spring environment anymore in this project, I need to change this mapper component model to another component model, and I need to use let me check. I need to use a GSR 330 just to be able to auto-wire my car mapper into my service, into my car service IMPL using Micronaut environment. If you navigate to the documentation, you can see that generated mapper is annotated with named and singleton and can be retrieved via inject. So if I map as GSR 330, it can be retrieved via inject. That's exactly the behavior I need. So let me get back to my car service IMPL, and I can inject my car mapper into my service. And let me copy paste my service and service IMPL. I just copy paste my code from previous project. And let's get back to implementation and add implementation. So I just copy this because my service logic is not gonna change and it should work. Yeah, and not found exception is not created, so let me copy paste it. Exception class. And let's add an dependency. Yeah, now we can see that our car service IMPL doesn't have any error. Let's create the latest layer is controller. Let me create package and let me create car controller. And car controller doesn't have REST controller annotation anymore because Micronaut has another set of annotations for the controller. It has controller, and inside the controller we can specify request mapping. So we can just specify car. If you check the differences between car controllers and in Spring and Micronaut, as you can see, we used REST controller and request mapping to specify that request mapping car will be responsible for car controller. So right now we need only one annotation, it's controller, and we can specify the request mapping inside controller annotation. Just like that. So, and we also need required ars constructor. And let's create methods. First of all, let's auto-wire our car service and create first method get car by ID. We specify annotation, it's get, and we specify the URL, and it's pretty much the same. If we want to specify placeholder, we just open these braces and specify the value for placeholder, and we create method the same way as we created for the previous Spring Boot project, and path variable long ID. And let's create another method, find all. And the next one is post method, and we gonna make it save, and we need a body car DTO, and we use car service save car to create or update car. And since we are using a validation in our car DTO, so to enable this this validation, we also need additional annotation in our controller. It's valid, and to make this controller applicable to this valid annotation, we need mark this controller as validated. And our validation will be applied. And if we want to return some status, as you remember previously, we created a response entity as void, and we just put created status with no body. In the Micronaut, we can use annotation, and we can use annotation status, and we can specify the status for when we create or update our car DTO. We can specify status created. Just like that, and it will return created status to 1 if car will be created successfully. And the last method is delete. We also gonna delete by ID. And we need to specify status for delete, and previously we specified OK status, so let's specify it OK this time. And that's pretty much it. But when I tested first implementation of this Micronaut, I noticed a lot of some errors with session closed and Hibernate, because I do mapping and map nested fields from this car entity. As you can see, brand has fetch type lazy, and it can lead to the exception like no session. So I just need to mark my service methods as transactional to avoid such behavior if I work with multiple entities or with nested entity in the same method. So for save, I use transactional, and I can be sure that this save will be executed in transaction. The same I can do for find all and for find by ID, because in this, when I was testing these methods, when I prepared this tutorial, I found that when we map brand name from the brand entity, and it shows session detached, session exception from Hibernate. We can fix this by specifying fetch type eager, but I don't like specifying fetch type eager. I wanted to make this project as much similar as the previous one, and in previous we had lazy, so we need to specify transactional annotation on our methods, which For example, for delete, we don't need transactional because we deal only with one entity. But for example, for save or for find all, we need specify transactional annotation, or we can specify for the car entity, we can specify fetch type eager. Okay, and let's move on. Let me close all tabs. What else do we have in the previous project? Let me check. As far as I remember, we have our custom login filter for specifying logs, and we also have our exception controller advice to specify the custom exceptions for the errors. So let me write controller advice. Let me navigate to the exception and create new package. Let's call it handler. Micronaut doesn't have oh, sorry, I use the wrong project, sorry. Micronaut doesn't have controller advice, but it has own tools for catch global exceptions and return responsive error message back to the client. So let me navigate to exception. Let's create new package and call it handler. And let's create a first class. We're gonna catch not found exception and handle this exception and return the responsive message to the client. Not found exception handler, and let me implement the handler of this class. So first of all, we need to add annotation singleton just to mark this class as component of the context. So this class can be injected in the context of our Micronaut. And then we need produces annotation. This annotation says that media type produces a particular component. And we also need an annotation requires that shows that this class requires additional classes. For our purpose, it's not found exception. Requires, just like that. And we can specify classes as an array. So we need to specify not found exception, our class, and we need to specify exception handler. Exception handler, it's a class from Micronaut. Sorry, wrong import. And let me auto-wire correct exception handler. I need to import Micronaut HTTP server exceptions, and I need my class to implement exception handler, and I specify not found exception and HTTP response, and I'm ready to implement my handler. And I say if I catch my not found exception with this handle will be triggered, so I can specify logic in my return statement. So I need to, as you remember, let me show you the previous implementation in the controller advisor. If we catch not found exception, we returned response entity with error message and local date time now. Let me copy paste, because we want to achieve the same logic as the previous application. And for example, we don't have response entity for now. We have HTTP response in Micronaut, and the rest is the same. HTTP response has method BET request, which applies specific status for BET request. and we can specify message and time for our body error.to, which we copy pasted from the previous project. And we are good to go. This class will handle our not found exception. If, for example, we want to handle a custom exception, which will be triggered for our DTO validation. As you remember, in this Spring Boot, we had to catch method argument not valid exception and override the message from default Spring message to our custom message. In Micronaut, we need to handle another exception. It says constraint constraint exception handler, and to tell you the truth, it was quite hard to find how to override this exception, but I found this solution. Let me create my constraint. Because the logic is not the same as for our custom exceptions, since constraint exception is custom from a Micronaut, we need to override this constraint exception handler to our own. So we say that we extend our constraint exception handler from Micronaut it locates in IO, Micronaut, validation exceptions, constraint exception handler. If you want to avoid this ugly path, you can just call your class with different name, and you will be able to avoid this path. But I wanted to show you that we implement our own constraint exception handler instead of the constraint exception handler from IO, Micronaut validation exception. This exception handler, constraint exception handler is responsible for handling this DTO validations. It's the same as this method argument not valid exception was responsible for handling validation exceptions in Spring. Let me get back to my project, and we need to implement method handle. Exactly, we need not to implement it, but we need to overwrite it, because since we extend the functionality of this class, we can override this handle method, and we can use our own implementation of this handle method, and we will override the behavior of this class. So we create public HTTP response handle, and we can handle HTTP request and constraint validation exception. Constraint violation exception. And that's how, using Java inheritance, we can change the behavior of the parent class. And let me return HTTP response, bad request, and with body, with our custom body. And let me specify the body error DTO builder. Message is exception get message, and the time is now. And let's add annotations, produces and singleton, and we also need annotation replaces. This annotation says that this constraint exception handler, our own constraint exception handler, will replace this constraint exception handler from Micronaut. So we say that this replaces this Micronaut And that's how Micronaut will know that we want to use this class instead of custom one. And let me add requires, as we did for not found exception. Let me add classes. Just like that, and it should work. And I guess we are done. Let me try to run the application and see if it works. Let's click app. And as you can see, startup completed. Default port is 8080, the same as for the Sprint. So let's open our Postman. We have saved our previous requests from Postman. Let's trigger car, and we have an internal server error. Let me check why. Let me navigate to the... As you can see, the error is that car entity repository not found. That's because in this Sprint, we don't need to mark our interface as repository, but in Micronaut we should. So let's add annotation repository, and our interface will be marked as repository in Micronaut environment. Let me restart the application. Previously, in previous versions of Sprint, this repository also was required, but as you can see in new versions of Sprint, repository annotation does not required anymore in the repository classes. But in Micronaut, you should add repository to mark interfaces as repository. Let's trigger list all once again, and we can see empty list. Let's create some car. Let's hit, and we also receive an error, no bin introspection available for type car DTO. Ensure that class is annotated with annotation introspected. What does it mean? It means that we should add introspected annotation to our car DTO, and let's add it. Let's add introspected. And if you navigate to the documentation of this annotation, it says that this annotation indicates a type that should produce bin introspection and compilation at compilation time. It means that this is annotation for your bin. If your class is gonna be used inside the scope of Micronaut environment, I mean like a usual bin, it should be marked as introspected. And also, if your class is used to return responses or receive requests, your class should be marked as serdable to allow Micronaut to serialize it and deserialize it. So let's add annotation serdable, and let's restart our application. This annotation allows can be applied to type that indicate that it allowed to be serialized and deserialized and form a format like JSON. And let's hit save once again. We save Tesla Model 1 year 2022, and you can see status is created. Let's hit find all. As you can see, everything looks fine. Let's create another entity and hit send. Everything is fine. Let's check if our validation works as we expected. Let's assume that we don't pass a model. Hit send. As you can see, this is our, now it's an internal server error, and this is bad. No serializable annotation is present for error DTO. Okay, what we can do in this case, just to make a quick fix, we can just remove this builder annotation. And let me just change this constraint exception handler. And instead of builder, just create a simple error DTO. Let me create like this new error DTO and specify exception get message and now. And change the same for our constraint exception handler and not found exception handler, because it can take some time to investigate this bug. And let me restart the application. I guess it has something to do with Lombok builder. And let me hit send once again. And as you can see, everything is fine now. We can see a message that car should have a model. And we have a time. If we hit send and send all the brand, model and year fields, we can see that car was created successfully. And since we restarted the application, we have only one car. So if we want to get car by ID, we receive car. If, for example, we want to get car by non-existing ID, we receive car not found by ID 10. Pretty good message for your front end or for other client you use. And status is pretty obvious what happened exactly. And what else can we do? Can delete. Yeah, let's delete car by ID. As you can see, status is OK and our car was deleted. And I guess let me, let me show you the latest, the final one. Let's update this car. Let's update car with ID 2 and change the year, for example, to 2019. Let's hit send. As you can see, detached entity pass to persist, and we can just use the same save for Micronaut as we used for our Spring. So because our Hibernate can just distinguish between the save and update in Micronaut, since we have this problem, what we can do, we can say if car DTO has ID, okay, and if it's not null, it says that we want to update entity, we can call car repository update and car entity. And if we have, for example, missing ID, we can just save. And I don't think we need brand if we update, but let's restart and check it out. In Spring, Spring implemented for us this logic underneath, but in Micronaut we have to use different methods for update and save. Let's restart application. Let me create first of all, let's create entity, and we created. And let's try to update it. Let's pass ID and let's change, for example, the year. Let's hit send, as you can see, and now it works fine. If we hit it once again, we see updated year. That's how we can fix this detached entity exception. And you can also create different methods. For example, create and update car DTO. You can specify a logic like this if car DTO has ID, and usually you will need, in real projects, you will need different REST endpoints for update and create. But anyway, you can see that Micronaut is pretty similar to Spring Boot, and you can easily migrate from Spring Boot to Micronaut and vice versa. And that's all for now. I hope you liked the video. Don't forget to subscribe to the channel and see you soon.